This is a Math 3 summary video for the lesson titled Segment Lengths in Circles. This is a develop understanding task. The purpose of this task is for students to explore relationships between the lengths of chords, secants, and tangents in a circle. In this video, I'm going to summarize the relationships that are discovered while completing the lesson. If you have not yet attempted the discovery questions in the lesson, where you measure different segment lengths and look for relationships, then please pause this video and complete this lesson. To summarize the relationships that exist, I'm going to look at an image of a circle, name the types of segments that are intersecting in the circle, and then find the equation that represents the relationships between those segments. Let's start with this one on top. This image shows two intersecting chords. Remember that chords are segments that have endpoints on the circle. When you have two intersecting chords, if you multiply the two segments that make up the chord, the product is the same as the product you get when you multiply the two segments of the other chord. Specifically, if you multiply x times y, it equals the same thing as w times z, where w, x, y, and z represent the lengths of the segments in the diagram. Next, let's look at a circle that shows two intersecting secants. Remember that a secant passes through a circle in two different places. The relationship that exists here is that you can multiply the length that is on the outside part of the secant times the whole secant, and that will equal the same thing as the length of the outside part of the other secant times the length of the other whole secant. Specifically, y times the quantity y plus w is equal to z times the quantity z plus x, where w, x, y, and z represent the lengths of segments in the diagram. Now let's look at a secant intersecting a tangent. Remember that a tangent intersects a circle at exactly one place, even if it is drawn as a ray or a line instead of as a line segment. This relationship is similar to the last one. For a secant, if you multiply the outside part of the secant to the whole secant segment length, it will equal the length of the tangent squared. So if w, y, and z represent the lengths of the segments in the diagram, y times the quantity y plus w is equal to z squared. Next, let's look at two intersecting tangents. If two tangents intersect, then the length of the segments z and y, pictured in the diagram, are equal to each other. The last diagram shows a chord intersecting a radius at a right angle. When this happens, the chord is bisected, making x and w equal to each other. Alright, that's it for this video. Thank you for watching.